Hi everyone, welcome back to my channel Chemistry World by KK. So today's topic hybridization. So first, what is hybridization? Merging or mixing of dissimilar orbitals of similar energies to form new orbitals is known as hybridizations, and the new orbitals formed are known as hybrid orbital. So it is one orbital to form a new orbital. This process is known as hybridizations, and newly formed orbit is known as hybrid orbitals. Okay, it has some important points. So first point, hybridization is not a real physical process but is a concept which has been introduced to explain some structural properties which could not be explained by similar valence bond theory. Okay, in hybridization it explains some structural properties but could not explain some simple valence bond theory. Okay, next point, the number of hybrid orbitals produced is equal the number of pure orbitals mixed during hybridization. So okay, example, 4 hybrid orbitals are produced mixing 1 s orbital, 3 p orbital. So 1 plus 3 4. Okay, these 4 orbital pure orbitals. Next point, most of the hybrid orbitals are similar, that is they have identical shape and energy. Okay, most of the hybrid orbitals are similar, they have identical shape and energy. So next point, hybrid orbitals leads of the formation of bonds known as hybrid bonds. Okay, the next point, the hybrid orbitals follow Hund's and Pauli's principle. Next point, hybrid orbitals are dumbbell type, one loop large and one loop small. Hybridized orbitals show only head-on overlapping and thus form only sigma bonds. They never form pi bonds. Okay, this form only sigma bonds. They never form pi bonds. The hybrid orbitals are distributed in space as far apart as possible. So different types of hybridizations leads to different orientations. Types of hybridizations and orientation. Okay, sp hybridization, 2 hybrid orbitals at 180 degrees. 2 hybrid orbitals means 1 s orbital and 1 p orbital. In second, sp2 hybridizations, 3 hybrid orbitals at 120 degrees. That means 1 s orbital, 2 p orbital, total 3. Next, sp hybridization, 4 hybrid orbitals. So 1 is s orbital and 3 is p orbital. So total 4 hybrid orbitals at 109 degrees 28 minutes. The angle of hybrid orbitals is delivered by cos is equal to minus 1 by x. So x means number of p orbitals. So for example, for sp, cos minus 1, the angle 180 degrees. So next, sp2 cos 2 minus 1 by 2, the angle 120 degrees. sp3, so p3, x means p orbitals, so p3, there is 2, this 1, minus 1 by 3, angle 109 degrees 28 minutes. The order in which orbitals of hybrid set are written in the order of increasing. N, okay, main group element use the NS, NP and ND orbitals, okay, and thus here hybridization written as sp3d, sp3d2 and sp3d3. On the other hand, transition element used n-1d, okay, ns and np orbital, thus the hybridization written as d sp3 d2 sp3. Okay, let's see one by one. So first sp3 hybridization, sp2 hybridization and sp hybridization. In sp3 hybridization, so one s orbital and 3 p orbital to form 4 equivalent sp3 hybrid orbitals. Okay, so the angle is 109 degrees 28 minutes. The structure of sp3 hybridization is tetrahedral. Okay, one s orbital and 3p, okay, 2px, 2py, 2pz to form 4 sp3 hybrid orbitals. Okay, so this is the structure. The angle is 109 degree 28 minutes. So these types of sp3 hybridizations takes place alkanes, okay, C single bond C. So for example, methane molecule, okay, methane molecule CH4. In the formation of methane, each sp3 hybrid orbitals overlap axillary with the 1s orbit of hydrogen atom to form 4 CH bonds. Okay, so 1, 2, 3, 4. The angle 109 degree 28 minutes. Okay, these are all sigma bonds. In sp2 hybridization, one s orbital, 2 p orbital form 3 equivalent sp2 hybrid orbital. So the bond angle 120 degrees. The structure of sp2 hybridizations trigonal planar. Okay, one s orbital, 2p, that means 2x 2p form sp2 hybrid orbitals. So the bond angle 120 degrees. This type of hybridizations takes place alkenes. Okay, alkenes example ethylene, structure CH2 double bond CH2. Okay, alkene means double bond, alkane single bond. So the structure in ethylene, the formation of ethylene, one of sp2 hybrid orbitals of carbon atom overlaps axillary with one of the sp2 orbital of another carbon atom. Okay, the two sp2 hybrid orbitals of each carbon atom overlap separately. Along the axis, 1s orbital is one of the orbital of the hydrogen atom. The pure p orbitals, one of each two carbon atoms overlap the another p orbitals. Okay, like this. The bond will be formed. The new bond is formed. The new bond is known as pi bond. Okay, so finally C double bond C, so H, so 2H, 1H and another one, this is H and H, the bond angle 120 degrees. So in these both bonds, one bond is pi bond, it is newly formed bond and it is sigma bond. Okay, next sp hybridization. So one s orbital, one p orbital form two equivalent sp hybrid orbitals. The bond angle 180 degrees and the structure is linear structure, okay, 1s and 1p to form sp hybrid orbitals. So this type of hybridizations takes place alkenes, that means triple bond. So example acetylene, okay, C double triple bond C H H, the structure is this, and so same as the sp2. So these sp hybrid orbitals of one of the carbon atom is overlap the another sp orbitals. The p overlaps auxiliary with the another sp. The bond will be formed in the two bonds, in the three bonds for acetylene. So two bonds are pi bond and one bond is sigma bond, okay. So this is the today class. Did you understand the concept? Like, share and subscribe. Thanks for watching, and if you want any particular topic in chemistry 11th to PG or MSc, please comment me. I will explain the topic. Thanks for watching.